Okay, so we have this interesting exponential equation here, and we will be looking at two cases. So let's look at case one. So for case one, we have 4 raised to the power x equals x raised to the power 4. We could try to eliminate x here by multiplying the power here and the power here by 1 over x. So we now have 4 raised to the power x times 1 over x equals x raised to the power 4 times 1 over x. So x cancels x. We just have 4 remaining. We just have 4 equals, then here we can write this as x raised to the power 4 bracket raised to the power 1 over x. And then, so because the power in here and the power outside here, they are commutative, I can swap them. So I will end up having 4 equals x raised to the power 1 over x coming inside and the 4 staying outside. It doesn't matter, when you multiply them, you still get the same value, which is 4 over x, since they are commutative. Then now I can try to eliminate this power 4 by multiplying this power here, which is 4, by 1 over 4, and multiplying the power here. The power here is 1 actually. So I'll multiply this 1 here by 1 over 4 also, just to eliminate this 4. So times 1 over 4. Then this one also times 1 over 4. So this cancels this, and I have 1 over 4 times 1, which is still 1 over 4. So I have 4 raised to the power 1 over 4 equals, this one will just be x raised to the power 1 over x. So now look at the left hand side and right hand side. You will notice that they are now the same. In fact, the left hand side is a replica of the right hand side. Notice that you have the base, which is x, and you have 1 over x again, this x being the same value as the x here, and here the same thing, the base being 4, and you have 1 over 4, the 4 being the same value as 4. In this case, we can now equate corresponding terms. The base are corresponding and the powers are corresponding. So I can equate the power, which is 1 over 4 equals 1 over x, since we now know that left hand side and right hand side are exactly the same, both the power and the base. So 1 over 4 equals 1 over x. So 1 over 4 can be equals to 1 over x. Then you can cross multiply, just x times 1 is x equals 1 times 4, 4. We have x equals 4. Or you can just equate the basis, x equals 4, if you are equating the basis. So case 1, for case 1, we know that x equals 4. So let's look at case 2. So for case 2, we're still going to write out the question. 4 raised by x equals x raised to the power 4. Let me write that one out. 4 raised by x equals x raised to the power 4. So for case 2, I'll rewrite, this is case 2. Let me write it out. Case 2. I'm going to rewrite 4 as 2 raised to the power 2. So 4 becomes 2 raised to the power 2. I'll still leave my x outside, equals x raised to the power 4. And now, because the 2 and x, they are commutative, I can swap them. The x comes inside the bracket and this 2 stays outside. This power 2 stays outside. So it now becomes 2 raised to the power x, then the 2, this power 2 stays outside, equals x raised to the power 4. And now I can try to eliminate these 2 by multiplying the power 2 here with 1 over 2, and this power 4 with 1 over 2, so that these 2 can go. So times 1 over 2, and this 4 also multiplied by 1 over 2. So 2 cancels 2, then 2 in 4 is 2. So finally, I have 2 raised by x being alone on the left hand side equals, then I just have x raised to the power 2 being alone on the right hand side. And in this case again, I can try to eliminate these 2 by multiplying this power again by 1 over 2. And also remember, anything you do to the right hand side, you also do to the left. I also multiply the left hand side by 1 over 2. So times 1 over 2, here also times 1 over 2. So this cancels this, and here I now have 2 raised by x, all in brackets, 1 over 2 equals x. And of course, the x has a power 1. So again here, I'm going to swap them since they are commutative. The 1 over 2 stays inside, and the x will now be outside. So that will be 2 raised to the power 1 over 2 raised to power, the x now stays outside, they are commutative. If I multiply, I still get the same 1 over x over 2 if I multiply them. This times this gives me x over 2, and also this times this gives me x over 2. That is commutative law. No matter how you swap them, you get the same value when you perform their operation. So equals x raised to power 1. Then, of course, I will try to eliminate x by multiplying here by 1 over x and also multiplying here by 1 over x. Remember, anything you do to the power on the left-hand side, you also do to the power on the right-hand side. So that's times 1 over x. And also this 1 will multiply by 1 over x. So x cancels x. And I have 2 raised to the power 1 over 2 being on the left-hand side. 2 raised to the power 1 over 2 equals, then here now 1 times 1 over x still gives me 1 over x. So I have x raised to the power 1 over x. Now in this case, notice that the left hand side and right hand side are the same. The left hand side is a replica of the right hand side, or the right hand side is a replica of the left hand side. So notice we have the base being 2, and here we have 2 here as the denominator, and we have 1 here. Here again, we have x here and we have x here being the same as the base. It means I can now equate corresponding terms. So I can equate 1 over 2 equals 1 over x. Then if I cross multiply, x times 1 is x equals 2 times 1 is 2. Or I can just equate the basis. 2 equals x, or x equals 2. If I equate the basis, x equals 2. So this is it. So for case 1, we got x equals 4, which also satisfies the equation. For case 2, we now got x equals 2. So these are the 2 solutions to the problem there. And remember, we are considering a restriction whereby the value of x is a member of integers. So that's it.